A couple of years ago, these bricks here have been one of the most favorite toys of my kids. And with this video, I will explain to you what those bricks have to do with EWM. My name is Hendrik and this is another video of the series Reveal SAP EWM. Today's video is all about queues. And queues in SAP EWM are basically a container to hold warehouse orders. And they are especially important in the context of resource management, because in this context we have resources accessing these containers of warehouse orders to get new tasks. And those resources need to get one of the tasks from those queues, from those containers. And with this video, I will explain to you how the sorting within those containers actually works. So, for the sake of this video, this stack of bricks will be our queue, and within those queue, each of those bricks will be one warehouse order. And the question that I am trying to answer within the next 15 to 20 minutes is how EWM is sorting those bricks within the queue in order to give the resource the most urgent or most relevant warehouse order to be processed. This also means that we are not talking about scenarios where you have multiple queues, for instance, assigned to the resource group and then given in a specific sequence. So we are switching from one queue to the other. We are rather talking about the sorting within one queue. And this also means we are not talking about scenarios where one specific warehouse order is already assigned to the resource. This is also possible in EWM, but with this setup, there will obviously be no sorting within the queue if you have one order already assigned to the resource. For the agenda of this video, I thought it might be useful for you to first look at the sorting that EWM applies in case we have no pre-assignment at all. We will look into this and reveal the technical details before we look at scenarios where multiple warehouse orders are pre-assigned to the resource. There is also specific sorting which is applicable, and at the end of this video I will obviously also reveal some party knowledge here. We will look at the sorting of physical inventory documents as well as the sorting in the context of interleaving. Let us start with answering the question how the sorting works technically, and for this purpose we have a quick look into the SAP help text before we look into the coding. And SAP says that if more than one warehouse order falls within one of these queue classification, the warehouse orders are sorted as follows: in ascending order by latest starting date, in descending order by execution priority. So we have two sorting criteria here. That's at least how it looks like based on the SAP help. And for those two sorting criteria, it's important to understand how the value is being calculated. And for the LSD, I created and published a video a couple of weeks ago. I will link it here in the header part of the video. The LSD is calculated by taking the warehouse order due date and subtracting the sum of the planned execution duration and the planned movement duration. I will not go into detail here. If you are not familiar with this concept, I suggest you to look into the other video or blog post about that topic. The prioritization is calculated, or the priority value for the warehouse order, both values are saved on the header of the warehouse order, is calculated by the weighting for the bin access type times the priority for the bin access type value, plus the weighting for the HU type group times the priority value, plus the weighting of the warehouse process category times the priority value. And also here, I will not go into detail. There is a very good SAP help text along with some examples about that topic, and I will link this help text below the video description. And also here, I recommend studying that help before we go into the details here, because that helps you as some, let's say, foundational knowledge to be able to follow me within the next minutes. As I said before, those two values are saved on, let's say, warehouse order header level, whereas it is saved in table WORSIC_TY, and this table holds the combination of resource type, warehouse order, and the two values that I mentioned before, along with some other data that are not too important in this context here. And the calculation itself is initiated in the function module SEWM RSRC WHO create, and this is also explained in detail in the other video that I mentioned before. And this function module calls WHO RSRC type set to actually write the result into the database. So in case you are struggling at some point here, you have the technical details and you know where you have to put a breakpoint in case you need to. Here's an example of a couple of warehouse orders sitting in the table that I mentioned before. And here you also see the LSD, which is a timestamp, date plus time, and the priority value. And we learned before that EWM is sorting based on the LSD ascending and based on the priority descending. So the LSD with a lower value, meaning further in the past, has the highest priority. And if you have multiple values with the same LSD, EWM will sort by the priority descending. So the highest priority value has the highest priority. And we will see that with couple of examples later in the video. Just to make sure that I'm not losing you, that has been our queue. Those different bricks are our warehouse orders, and the resource that is then trying to get the next warehouse order from the queue takes the one from the top. And the sorting here makes sure that the one at the top is the most urgent one. And we learned now that those bricks are sorted first based on the LSD and second based on the priority. So the brick at the top, the warehouse order at the top, has the oldest latest starting date. And if there are multiple bricks with the same latest starting date, then the one at the top will be the one with the highest priority value. If you understood that concept, then you have understood half of this video already, but I promise you I will reveal some more secrets within the next minutes. I do think that you understood the concept as such now, and I also know that most of you are interested in the technical details. So we will now start with a quick code review, and we will start with the scenario where we do not have any pre-assigned warehouse orders to the resource. So everything which is sitting in our queue is not pre-assigned to the resource. The resource is accessing either in system guided or system guided by queue mode, and we are now looking into the queue to find the most relevant or most urgent warehouse order. The selection technically is initiated by function module RSIC WHO select, which is then calling these two guys here, which are then initiating the select onto table SEWM WO RSIC TY. That is the table that I showed you before with the example records, and you see here in the select that the result is already ordered by LSD priority warehouse order. So we see that already during the selection SAP is ordering the warehouse orders, and we see that LSD is the most important factor of the ones that we saw before, following by the priority. And this is new here, the warehouse order number is a third criteria, one that was not mentioned in the help text before. And we see that the same sorting is then being applied once the result of the selection is handed over to function module src quellif queue check. So we have a sort command here, and maybe one of the more technical oriented guys, one of the developers from you might be able to explain that to you, why EWM is sorting here twice, or what the order by command that we saw before might not have covered, that this sort command is covering here. But again, this internal table that was handed over and selected by the function module that we saw before is now sorting again based on the LSD, again based on the priority, and by the warehouse order number. So this is new, and we understood now that in case we have multiple warehouse orders with the same LSD and the same priority, that at the end the warehouse order number will decide about the sequence. So that means the warehouse orders which have been created first, so have a lower warehouse order number, will also be suggested for processing first. I prepared one example for you where you should again see how EWM is sorting. You see the column LSD. We are right now in the internal table during runtime, which is holding the warehouse orders which could be processed by the resource. And you see here at the top of the list we have the oldest warehouse order. So that one here is from February 10th, from 8:31, and you see here the next ones coming in are from February 13th, 8:19, and here at the bottom, February 13th, 8:25. And what you also see, if the LSD is the same, you see for those two here at the top, the LSD is the same, you see that the sorting is based on the priority. So the highest priority value is sorted at the top. You see the same also with this example. Here 3 warehouse orders with the same LSD and the sorting based on the priority. And the example here at the bottom, where we have 2 warehouse orders with the same LSD and the same priority, here you see that the lower warehouse order number is sorted at the top of those 2. And if you understand this table here, then you understood the concept of how warehouse orders are sorted in the context of normal processing of non-pre-assigned warehouse orders. Slightly different context now. We do not only have a queue that the resource is accessing to grab one of the warehouse orders. Now we have a queue, but within this queue, some of the warehouse orders have been assigned already to me as a resource. So assume from this queue here, let's take this 6 warehouse orders have been assigned to me already. For example, by the warehouse supervisor using the warehouse monitor. So those guys are pre-assigned, and we now have a look at the code how EWM is sorting those pre-assigned warehouse orders. As I just mentioned, the pre-assignment can, for instance, be done via the warehouse monitor. You have the method to assign one or multiple warehouse orders to a resource, which is then executed and written into the database by function module SEWM as ICWHO select. In our context, it's of course only interesting in case more than one warehouse order is assigned to the given resource, because if only one warehouse order is assigned, then the sorting is quite simple. There is no sorting actually. And I have to disappoint you in case you expected some surprises here. We do not have any. As you can see here, different line, same function module, same sorting. LSD, priority, warehouse order number, nothing special here. Just keep in mind when warehouse orders are pre-assigned, when multiple warehouse orders are pre-assigned, they of course have a higher priority than the non-pre-assigned ones, but the sorting within the block of pre-assigned warehouse orders is the same as the sorting of the block of non-pre-assigned warehouse orders.
Sorry to bother you one more time, and again, forgot to remind you about hitting the subscribe button. Please make sure to do so. It will motivate him to create further videos and you'll be notified about any new releases.
A quick look into how you can enhance the sorting logic here with or without pre-assignment. And there is actually only one possibility that I found, and I guess that is actually the only one that you can use to directly influence the sorting, which is body SEWM X RSIC pros cell. And the comment and the coding that I found here, which pretty much summarizes what the body is doing, is that you get a list of manual assigned warehouse orders and can resort them or delete warehouse order from the list or return a new warehouse order according to your own selection. You must set LG, num, WHO, and content at least. And you see already here an important hint that it seems to be relevant for manually assigned warehouse orders only. And I was a little bit surprised about that, checked the code, and found that it is indeed called from the function module that we know already, that we saw before, right after the standard sorts the warehouse orders which have been assigned manually. And with the body that is called from the subroutine, you can then change here this internal table with the standard sorting. What I did not find, and that really surprised me, is a call of this body right after the sorting of non-manually pre-assigned warehouse orders. And I could really not find a good reason why this is not being called in this context. You see that here again. This is the call that I showed you on the previous slide, and this is called in case the warehouse order selection with manual pre-assignment has happened. And here, couple of lines later, you see we are already here in the 700s, and here EWM selects the warehouse orders which have not been pre-assigned, and you see that the subroutine filter WHO is actually being called, so the same which is later also being called for the context with manual pre-assignment, but there is no call of the body before, and I was asking myself, why the heck does EWM not call the body over here? Maybe one of you has a good explanation. Maybe somebody from the SAP team is actually watching this video and can drop a comment just below here in the comments. That would be really helpful for me personally and probably also for everybody else to understand why this is not offered in this context. Alternative option though to enhance the sorting indirectly is to enhance and manipulate the criteria which is used for sorting. And this is, as we learned before, mainly the LSD and the priority. And for enhancements and changes of the LSD calculation itself, I made a very comprehensive video before. I will link it here on the top of this one. And for the prioritization, you can use body SEWM X RSIC pros WO, where you can override the standard priority value based on your custom requirements. As promised before, we will close this video with a little bit of party knowledge, and we will jump now into the area of task interleaving. And with task interleaving, if you don't know the concept, I have another video where I explained it, and I would recommend watching that before. In task interleaving, you are switching between at least two different queues. And you have different queue types, and the classical setup is that you have one queue with put away task and you have another queue with removal task. And whenever your resource, for example a forklift, a crane, whatever, is dropping one HU which is to be put away, it should pick up another HU which is to be removed. Now I picked up 2, but you got the concept, I think. And in this environment, we are not sorting the warehouse orders in the same queue where we are right now already, but rather sorting the warehouse orders in the other queue. So I just finished the warehouse order in this one here, and now I need to sort the warehouse orders in this queue. So I need to decide, once I finished that one here, which of those is the most appropriate one to be processed next. And in this context, we have some kind of a special logic, something that I did not find at many other places in the documentation. And this is something I will show to you right now in the coding so that you understand every little detail. I will reveal the secret right away at the beginning of this section, and we have an additional criteria for sorting, and we have something that I did not really understand. A comment here from SAP that in the context of task interleaving, we are resorting based on LSD, priority, and distance. And within the next slide, I will show you that this is actually wrong and how this is actually working. In addition to the LSD and the priority, we seem to have the consideration of the distance here. But let us just look how it actually works. And the sorting itself is happening in subroutine WO sorting by dist calc. And what is happening here is that EWM calculates the distance between the current position of the resource and the first bin of every warehouse order in the next queue. So I told you already we are switching between queues, and we now want to figure out what is actually the closest warehouse order from the other queue. So the one that I can reach with the lowest travel distance. And for this purpose, it is looking at the first task of all the WOs in the other queue. The sorting at the end, here you see it technically happening at the end of the subroutine, is done by LSD and distance. So I do not find the priority anymore here. And I do not know, just to jump back 2 slides, why it says priority over here. Anyhow, we see and we understand now that we basically replaced the priority value from the warehouse order with the distance value. So the priority of the warehouse order is not relevant anymore. As this is a little bit more complicated, I will just quickly get back to my bricks to explain the concept. So I'm the resource and I'm processing warehouse orders in this queue. I just finished that warehouse order, and the last task of this warehouse order brought me to position X. So I'm sitting right now here at my desk. This is my current position. And based on the interleaving settings, I know that this is the next queue from where I need to take a warehouse order. So EWM is then, of course, calculating the LSD, reading the LSD. It has been calculated before. But in addition to this, EWM checks where the first task of each of those warehouse orders would have to be picked. So that, of course, only works in case you maintain coordinates for your bins. That's something that is, of course, a precondition. But it might be the case, and let us assume that those 2 warehouse orders here have the same latest starting date. And the first task from this warehouse order has to be picked from a bin, which is 5 meters away from me, from my current position in that direction. And the first task of this warehouse order here is 20 meters away from my current position on the other side of the warehouse. And EWM then says, okay, I put that one here on top of that one so that this one is being processed first, so that I can minimize the travel distance for the resource. And that, as we saw, is replacing the priority value as the sorting criteria. Last comment for this slide before we close the section with another example, and I could not hold me back doing this. And sorry upfront, SAP, I'm more than impressed by the coding that you deliver, and I'm more than grateful to be able to work with that system. But why the hell it is not possible to deliver that coding without so many spelling errors in the comments? Yeah, I don't know whether the pretty printer can do that, or why it cannot do it, or why there is no AI to check the code before it's delivered to the customers. I mean, sorry, it's a $300 billion company, and you should be able to deliver your code without spelling errors in the comments. Anyhow, let's proceed with an example and close this section. And with this example, I just try to visualize the way of sorting again. And you see here that I built an example with multiple warehouse orders having the same latest starting date. So this block here and this block here, the LSD values are the same. And what you see right away is that the priority here is not considered anymore. With the examples that we saw before, in the non-interleaving context, you always saw the one with the highest priority value at the top of the list. And now you see the one with the lowest distance value at the top of the list. You see it here with the 12, you see it here with the 3. Although here the 5 higher priority, 4 higher priority, it's not considered anymore. We are only considering the distance, so trying to minimize the travel distance for the resource. You can enhance that. Actually, SAP by themselves is using body SCWM x TDC start with the example and also fallback class x TDC start D, where the distance is being calculated. So even if you are not maintaining the coordinates in your bins and you are not delivering the master data that EWM can use to appropriately calculate the distance, you can jump in here, copy the class, replace this with your own implementation of the body, and manipulate the sorting, all given that the LSD is the same for all tasks. Manipulate the sorting here by providing different distance values based on your custom requirements. Last point before we really wrap him up here is the physical inventory. And you know that for physical inventory documents, we always have warehouse orders holding the PI document items. And those warehouse orders are then processed by the resources while processing and counting the PI documents. And there is nothing new here. We are also using the LSD and the priority for sorting those warehouse orders in the queue. So same concept as for non-PI document warehouse orders. The only difference is the way of calculating the values which are used for the sorting. And the LSD calculation, I explained that in the other video that I mentioned already a couple of times here, is based on the planned count date. So this is the due date that you use then to subtract the planned movement and planned execution duration, and the priority is coming from the PI customizing in this context. That's actually all you need to know about the sorting of warehouse orders for PI documents in the queues. And that finally wraps up this video. I would like you to take away 4 points. The first one is sorting of warehouse orders which have been pre-assigned to the resource is the same as sorting of warehouse orders which have not been pre-assigned to the resource. We are taking the LSD, the priority, and the warehouse order number, and that's the same in both cases. Second point, if you want to enhance the sorting, there is a body, but you can only use this body when you are working with manually pre-assigned warehouse orders. If warehouse orders have not been manually pre-assigned, the only thing that you can do is to enhance the sorting criteria, which is the LSD and the priority. How to do that, you can find it in the other blog post that I will also put into the video description. Point number 3, PI documents are sorted in the same way as normal warehouse orders, LSD and priority. The only difference is that those values are calculated in a different way. Also explained in the other video. Last point, context of task interleaving. Different queues and you switch between the queues the priority as a sorting criteria is replaced here by the distance between me as a resource and the potentially other warehouse orders to be processed next. And for that purpose, EWM calculates the distance between me and the first task of all those warehouse orders. Last but not least, I would like to close this video with a big shout out to Ole Kirk Christiansen, who is actually the inventor of those Lego bricks and who not only gave my kids a great time when they were young, but also enabled you now to understand the sorting of warehouse orders within queues. My name is Hendrik and I hope to see you back with the next video. Have a good time, have a good learning.